Consumer GPUs master FP8 training. The democratization of local AI training took another leap forward with Unsloth's announcement of FP8 reinforcement learning on consumer hardware requiring less than 5 GB of VRAM. The release builds on techniques the DeepSeek team showcased earlier, demonstrating the effectiveness of FP8RL with GRPO, Group Relative Policy Optimization. For context, FP8 refers to 8-bit floating-point arithmetic, a reduced precision format that trades minimal accuracy for dramatic memory and speed improvements. Unsloth claims their implementation delivers 1.4x faster RL training, 60% less VRAM usage, and 2x longer context windows compared to traditional BF16 FP16 methods. The hardware requirements reveal an important generational divide. FP8 support requires NVIDIA's RTX 40 series or newer, as hardware FP8 capabilities were only introduced with that architecture. RTX 30 series owners are left out in the cold for FP8 specifically, though standard GRPO still works. The community discussion highlighted forward-looking developments too. RTX 50 series cards introduce hardware FP4 support, which NVIDIA's NVFP4 implementation reportedly delivers close to BF16 accuracy despite initial skepticism when the 5090 was announced. Community response underscored the significance of this development. One user captured the mood. When RL training drops from enterprise H100s to consumer RTX 40X series, you fundamentally shift who can innovate. The gap between AI researcher and person with a gaming PC just collapsed. Developer Daniel Chen even claimed that models fine-tuned on custom datasets with this approach can be much better than GPT-5 and surpass reasoning models. Given sufficient data, a bold assertion worth watching. Platform support continues expanding, with AMD ROCm working unofficially and Apple MLX support planned for early 2025. CUDA kernel fusion speeds. On the inference optimization front, the llama.cpp community has been steadily pushing performance boundaries through kernel fusion in the CUDA backend. A detailed write-up shared on the project's GitHub discussions explains how single GPU users can enable ggml CUDA graph opt=1 for modest speed improvements. The optimizations particularly benefit MOE, mixture of experts models, with benchmarks showing the GPT-OS 20B model running at approximately 80% of theoretical limits on an RTX 5090. The discussion revealed the typical growing pains of cutting-edge optimization work. Some users reported regressions. One noted that partial CPU MOE configurations crashed while full CPU MOE worked fine, a bug quickly acknowledged and addressed. Another user on an RTX 3090 saw slower token generation with the graph optimization enabled on certain models, highlighting that these optimizations aren't universally beneficial across all hardware and model combinations. The developer's response was instructive. The problem is that the CI does not catch PPL errors yet, and Llama Perplexity does not catch TG, batch size =1, bugs, so it is possible to royally fuck up pretty easily. Multi-GPU improvements remain in active development, with promises of updates early next year. A helpful NVIDIA engineer contributed Blackwell benchmarks, demonstrating the collaborative nature of open-source inference optimization. For users experiencing issues, the advice is practical. Check build configurations, verify CUDA versions match official releases, and when in doubt, wipe the build directory and start fresh. One user traced phantom performance degradation to stale CMake cache entries from incremental builds, a reminder that the simplest debugging step is often a clean rebuild. Tackle context bloat. Context window management has become a critical challenge for agentic AI workflows, spawning a wave of tools built around Model Context Protocol (MCP). An SRE developer shared Code Mode Tune, an MCP workflow orchestrator born from frustration with multi-step automation, generating massive JSON blobs that exceed context limits. The tool enables predefined workflows, Kubernetes audits, log analysis, research queries, rather than chaining individual tool calls. Its compression scheme reportedly achieves 83% savings on structured data like K8's manifests, though only 4% on prose, making it most useful for keeping large datasets in context. Community feedback offered sophisticated alternatives. One detailed response suggested storing outputs as content-addressable blobs using SHA-256 hashes, passing only tiny summaries plus IDs back to the model, with tools to fetch slices on demand. The recommendation stack included Arrow Parquet or Message Pack for structured data, OpenRego for policy evaluation with delta surfacing, and isolated VM or containerized worker pools, gvisor, Firecracker, instead of Node's VM module for security. The underlying insight: graph-based architectures with durable workflows and slice-on-demand patterns fundamentally solve the context problem rather than fighting it through compression alone. Parallel efforts address different aspects of the MCP ecosystem. OpenPTC Agent implements Anthropic's programmatic tool calling patterns on LangChain, allowing agents to write Python code orchestrating entire workflows rather than making individual tool calls that return overwhelming JSON. The code executes in a Daytona sandbox, with only final outputs returning to the model, claiming 85–98% token reduction on data-heavy tasks. Another developer tackled agent attribution, building an open-source passport system that generates persistent RSA key pairs for agents to cryptographically sign their actions. The motivation: if an agent hallucinates and deletes a database table, there's currently no way to prove which agent did it or verify the instruction wasn't tampered with. Desktop clients and learning resources. The proliferation of local AI tools has created demand for polished desktop interfaces beyond browser-based solutions. Eskimo emerged as an llama-native desktop client addressing common pain points: browser tabs consuming memory, long chats becoming sluggish, and losing useful prompts. Originally a CLI automation tool, it evolved into a full desktop application with MCP support for both consuming external tools and being consumed as a tool by other agents. The developer emphasized treating themselves as the first customer, adding features they kept wishing other applications had. User feedback immediately pushed for editing capabilities, the ability to modify both prompts and AI responses within the conversation history. The developer's initial hesitation about response editing revealed a common misconception. Edits don't retrain the model, but rather modify the context window for subsequent generations. As one user explained, editing responses changes the history context, not the weights, allowing correction of misunderstandings that would otherwise taint the context going forward. This feature, available in commercial interfaces like po.com, proves essential for iterative refinement of AI-generated content. For those looking to master AI coding tools, a solo developer open-sourced a 24-unit Claude code learning curriculum spanning 4 levels from prompt foundations through autonomous skills. The structured approach promises 15 to 25 hours saved weekly after completing 13 to 20 hours of practice spread over 8 to 12 weeks. Each unit includes hands-on exercises with real code bases and progress tracking to measure ROI. The developer's philosophy: built it for myself, sharing costs nothing, gatekeeping is dumb. Cybersecurity AI goes open source. The Cybersecurity AI framework represents an ambitious attempt to democratize AI-powered security automation. Built upon foundations from Pentest GPT, CAI provides ready-to-use tools for reconnaissance, exploitation, and privilege escalation, validated through hack-the-box CTFs, bug bounties, and real-world assessments. The framework's case studies claim impressive results, uncovering vulnerabilities in Unitree G1 humanoid robots, including unauthorized telemetry to China-related servers, achieving top 10 ranking in the Dragos OT CTF 2025 while completing 32 of 34 challenges, and discovering critical flaws in ecoforest heat pumps affecting units across Europe. The decision to open-source CAI reflects pointed ethical arguments. The developers contend that advanced cybersecurity AI should be accessible to the entire security community rather than restricted to well-funded companies or state actors. More provocatively, they argue current LLM vendors are underreporting their cybersecurity capabilities, which they consider extremely dangerous and misleading. CAI aims to provide transparent benchmarks of actual AI capabilities in security contexts, with research publications claiming 4.5x improvement over human penetration testers in standardized evaluations. Complementing offensive frameworks, OWASP launched the AI Testing Guide as an open-source initiative for comprehensive AI system testing methodologies. The project consolidates multiple existing resources: the GenAI Red Teaming Guide, the Cloud Security Alliance's Agentic AI Red Teaming Guide, the AI Security and Privacy Guide, and the Top 10 for LLM Risks. The AI Vulnerability Scoring System adapts traditional CVSS principles to the AI domain, offering consistent risk ratings for model flaws, data weaknesses, and deployment exposures. Section: NIST pilots real-world AI evaluation. Academic and government research continues addressing the gap between laboratory AI testing and real-world deployment risks. NIST published the RIA 0.1 Pilot Evaluation Report, describing their novel approach to assessing AI risks and impacts through scenario-based interactions with human testers. The program acknowledges a fundamental problem. Current approaches to AI evaluation often do not account for risks and impacts of AI systems in the real world. The pilot methodology employed 3 testing levels across 3 scenarios. Model testing used standardized prompts to confirm basic capabilities. Red teaming involved 23 paid testers, $46 an hour, attempting to circumvent defined guardrails. For the TV spoilers scenario, trying to make the AI reveal plot points. For meal planner, attempting to get allergen-containing recommendations. Field testing observed 78 testers having natural conversations to simulate realistic deployment conditions. Dialogues were annotated across 11 dimensions, including harm and output, hallucination, coherence, and guardrail violations. The study introduces the Contextual Robustness Index, CORIX, a hierarchical measurement tool synthesizing multiple data sources into transparent, interpretable scores. Higher CORIX values indicate greater validity risk. The framework's explicit design for transparency enables organizations to understand exactly how scores are calculated, a crucial property for building trust in AI evaluation methodologies. While the pilot focused on relatively benign scenarios, the methodology establishes foundations for assessing AI systems in higher-stakes domains. Adversarial examples show their weakness. A research paper from Jilin University makes a counterintuitive argument. While deep learning models are vulnerable to adversarial examples, those adversarial examples are themselves surprisingly fragile. The core finding is that image-based adversarial examples exhibit heightened sensitivity to occlusion compared to clean samples. Slight changes that barely affect clean images can cause adversarial examples to misclassify across entirely different categories. The researchers introduced sliding mask confidence entropy, SMCE, to quantify this phenomenon. By applying a sliding window to mask local areas of an image and measuring how model confidence fluctuates, SMCE captures the inherent instability of adversarial perturbations. Their detection algorithm, sliding window mask-based adversarial example detection, achieves over 62% accuracy in most detection cases and up to 96.5% across various classifiers and attack types on CFAR 10. Critically, this approach avoids catastrophic overfitting, a persistent problem plaguing traditional adversarial training methods. The practical implications extend to critical AI applications in autonomous vehicles, medical diagnostics, and security systems. Rather than exclusively focusing on making models more robust, computationally expensive, and often incomplete, this work suggests leveraging adversarial examples' own weaknesses for defense. The researchers establish a positive correlation between detection accuracy and model robustness, suggesting that proactively identifying and filtering adversarial inputs can substantially improve overall AI system security without the resource demands of comprehensive, robust training. Training acceleration and new models. Hugging Face's TRL, Transformer Reinforcement Learning Library, now officially integrates with rapid-fire AI, promising dramatic acceleration of fine-tuning experiments. The core value proposition: teams often lack time or budget to compare multiple training configurations, even though such comparisons could significantly boost evaluation metrics. Rapid-fire AI enables concurrent execution of multiple TRL configs on even a single GPU through adaptive, chunk-based scheduling, claiming 16 to 24x higher experimentation throughput than sequential approaches. The technical approach splits datasets into chunks and cycles configurations through available GPUs at chunk boundaries, enabling earlier apples-to-apples comparisons and maximizing utilization. Interactive control ops allow stopping, resuming, deleting, and cloning runs from a live dashboard based on real-time metrics, avoiding wasted resources on underperforming configurations. The system supports SFT, DPO, and GRPO training through near drop-in replacements for TRL's existing configuration classes. On the model release front, NVIDIA published ChronoEdit 14b, a physics-aware image editing model enabling action-conditioned world simulation through temporal reasoning. Distilled from a 14b parameter pre-trained video model, ChronoEdit separates inference into video reasoning for latent trajectory denoising and in-context editing for trajectory pruning. The explicit physical AI focus, robot arm manipulation, object picking, temporal consistency, positions it for simulation and synthetic data generation. Meanwhile, Plei has released Baguettatron, a 321M parameter small reasoning model with an unusual architecture, 80 layers making it the deepest SLM in its size range, trained entirely on synthetic data. Despite limited training data, it reportedly outperforms similarly sized models on non-code benchmarks. Section Multilingual Speech and Agent Tools. Meta's omnilingual ASR models generated excitement for supporting 1,670 languages, with hundreds having literally never seen speech recognition before. The 1B parameter model runs on phones or IoT devices completely offline, requiring no cloud connectivity, a privacy win for edge deployment. The 7B zero-shot variant reportedly adds new languages with approximately 30 audio-text pairs rather than million-hour datasets. One commenter highlighted potential applications for endangered language preservation, describing attempts to create a Hawaiian language LLM for local universities and educational institutions. Developer tooling continues expanding across platforms. JRVS positions itself as an AI agent with RAG capabilities, web scraping, calendar integration, and code generation, notable for supporting both acting as an MCP tool for other systems and consuming external MCP servers. The project emphasizes local first operation powered by a llama or other local AI providers. For Go developers, GitHub Models Go provides a client library for GitHub's Models API with streaming support, rate limit tracking, and automatic token usage monitoring. A whimsical but practical project applies machine learning to birdwatching assistance. Built on Raspberry Pi 5 with an AI hat, the system uses OpenCV for image recognition, sending email notifications when it detects bird activity. It logs hourly bird counts and generates daily graphs to identify peak birdwatching times. While currently limited to detecting birds generally, future versions aim for species-level identification, though the article notes alternative approaches using audio recognition of bird calls may prove equally effective. Security incidents and data concerns. The 23andMe data breach settlement entered its final phases, with the U.S. Bankruptcy Court authorizing a settlement website for affected customers. The October 2023 cyber attack compromised personal information for approximately 6.4 million U.S. residents. Settlement class members, those who were 23andMe customers between May and October 2023 and received breach notification, may claim up to $10,000 for extraordinary claims, $165 for health information claims, an estimated $100 for statutory claims, plus 5 years of genetic monitoring services. The deadline to submit claims is February 17, 2026, with a final approval hearing scheduled for January 20, 2026. A more troubling allegation emerged from a Reddit discussion claiming Belgian federal police used bot accounts to manipulate public feedback on an EU impact assessment regarding data retention laws. The proposal would require companies to retain user data for law enforcement purposes. Multiple identical comments supporting expanded surveillance were allegedly attributed to Federale Polity, Belgium, in the EU feedback portal. However, skeptics noted anyone can enter any organizational affiliation in those comments. The claims remain unverified, and the post was removed from r/Europe for lacking credible sources. The discussion raised broader concerns about bot-driven manipulation of public discourse. One commenter observed that everyone and their mom has their own bot army now, a weaponization that arguably requires participation to avoid disadvantage. Others invoked dead internet theory, questioning whether meaningful human discourse remains possible amid coordinated manipulation campaigns. Whether the specific allegations prove accurate, The underlying anxiety about automated astroturfing influencing policy deserves serious attention.